One of the very important topics of the chapter of quadratic equations is quadratic inequalities. So what are quadratic inequalities? So the inequalities of the form ax square plus bx plus c is either greater than 0, less than 0, greater than or equal to 0, less than or equal to 0 are called quadratic inequalities. Now you will be expected to solve these quadratic inequalities. So how do we solve these quadratic inequalities? So the solutions of these quadratic inequalities can be understood through the graphs of quadratic functions. So we have already drawn the graphs of quadratic functions, that is y is equal to ax square plus bx plus c. So we have already drawn the graphs of this, we have them before us. So seeing these graphs, can you see where the value of the graph ax square plus bx plus c is nothing but y, where the value of y is greater than 0, less than 0, greater than or equal to 0, less than or equal to 0. Yes. So to analyze this, first observe these graphs. So if you want to solve the inequation ax square plus bx plus c is greater than 0, the first thing that you need to observe is whether the leading coefficient is positive or negative. So if the leading coefficient is positive, then you need to look at these three graphs. If the leading coefficient is negative, you need to look at these three graphs. So first, if the leading coefficient is positive. Next, when will the quadratic be greater than 0? When will the quadratic be greater than 0? So if discriminant is less than 0, it is always greater than 0. If discriminant is equal to 0, it is always greater than or equal to 0. The problem comes in this case. If discriminant is greater than 0, you have two roots alpha and beta to the quadratic equation. So as you can see, between the roots, the graph lies below x-axis. Outside the roots, the graph lies above x-axis. That means ax square plus bx plus c is less than 0 between the roots. Between the roots, if roots exist. If d is less than 0 and d is equal to 0, you don't have two distinct roots. So if there are two distinct roots and a is greater than 0, between the roots, the expression is negative, and greater than 0 outside the roots. So this is something which you need to remember. If the leading coefficient is positive, then between the roots, the expression ax square plus bx plus c is less than 0. Outside the roots, the discriminant, the value of the quadratic expression is greater than 0. And if discriminant is less than 0, that means you don't get any real roots, then the expression is always positive. If the discriminant is equal to 0, then the expression is always greater than or equal to 0. Now, if the value of a is less than 0, if a is less than 0, that is, the leading coefficient is negative, the analysis becomes just the opposite of what you have done here. Now, between the roots, the expression is positive. Outside the roots, the expression is negative. And if the discriminant is less than 0 and equal to 0, the graph is always below x-axis. That means the value of this expression is always less than 0. So if d is negative, it is always strictly less than 0. If d is equal to 0, it is less than or equal to 0. So this is about the quadratic inequalities. Let us try to write them concretely. So if I have to summarize this solutions of quadratic inequalities, the first point is, if a is positive, that is, if the leading coefficient is positive in your inequality, then ax square plus bx plus c is less than 0 between the roots and ax square plus bx plus c is greater than 0 outside the roots. That is, if the roots are alpha and beta, ax square plus bx plus c is less than 0 in the interval open alpha comma beta. And if you want the quadratic expression greater than 0, you need the value of x to be outside the roots, that is minus infinity to alpha union beta to infinity. So this is the solution for the quadratic inequality. And obviously you can find the roots only if the discriminant is positive. So if roots don't exist, if discriminant is less than 0, ax square plus bx plus c is greater than 0 for all x belongs to real numbers. So if discriminant is less than 0, that means the quadratic expression is always positive because the leading coefficient is positive. And if d is equal to 0, so ax square plus bx plus c is always greater than or equal to 0 for all x belongs to real numbers. So this is the summary of the quadratic inequalities if the leading coefficient is positive. And if the leading coefficient is negative, then what are the conclusions? Ax square plus bx plus c is greater than 0 implies between the roots. So if the leading coefficient is negative, the expression is positive between the roots. And ax square plus bx plus c is less than 0 outside the roots. So between the roots, the expression is positive. Outside the roots, the expression is negative if a is less than 0. And if you cannot find the roots, if discriminant is less than 0, then ax square plus bx plus c is less than 0 for all x belongs to real numbers. That means for every value of real numbers, the expression is always negative. And if d is equal to 0, then ax square plus bx plus c is less than or equal to 0 for all x belongs to real numbers. So this is the summary of the solutions of quadratic inequations which you need to understand. But when you're solving the quadratic inequalities, what you tend to do is you tend to make the value of a positive and always use the first analysis. So if you're confident with both the analysis, you can do whatever you want. The most general process is by just making a greater than 0 before solving any quadratic inequality. So let us try to do some questions based on this topic.